Okay, welcome back. This is lesson number 2 in the forces topic, and this is about contact and non-contact forces. Very easy stuff. It's nice key stage 3 stuff, okay, which is required at GCSE. Now then, here are some starter questions. Pause and have a go. So, we should know all these by now. If you don't, go back and review the previous lesson. We know what a quantity is. It's something we can measure. We can describe what a vector and a scalar are. A vector has size, magnitude, and direction. And we should be able to recall scalars and vectors. And there are some examples there. If you don't know those, go and learn them. There's a table in the previous lesson. We can represent vectors with an arrow, and we can draw it very simply with a scale diagram. Number 6 is interesting. Describe the difference between displacement and distance. Okay, very important that you should be able to do that. That could be a 2-mark exam question, for example. So, this is what we're going to look at today. Just to briefly go over what we mean by contact and non-contact forces, describe some of the effects of forces, and just generally, it's a really easy key stage 3 thing. Okay, you can read that. So, why do we learn about forces? It's because they operate all over the universe. From the nucleus of atoms, there's something called the strong force, which keeps protons and neutrons together. And there's also something called the weak force, which is indicated in things like alpha decay and so on. There's the electric force, which is related to magnetism. There's the gravitational force, which acts over distances. And in that example there, the moon exerts its influence on the Earth's oceans to cause the tides. And we also need to know about forces if we want to send things into space, make things move. We have forces of friction and air resistance, upthrust, thrust, etc., etc. So this is why we learn about forces. Okay, so let's just move these on. So forces involve interactions between objects, one object having some sort of influence on another object. Now, some forces can act over distance, so the objects don't need to touch. Gravity, electrostatic, and magnetic, they're the 3. Okay? You do not need to, say, touch 2 magnets together to get them to repel or attract. That force acts over a distance. Gravity acts over a distance. If you take me high up into the air and drop me out of an aeroplane, there's nothing between me and the ground. The force of gravity acts between us across space. Friction and upthrust are different sorts of forces because they involve objects touching each other. For example, friction, if you're trying to drag something across the floor, it's the contact between the objects which causes that friction. Upthrust is caused by the liquid or the fluid that you're in exerting a force on you to make you feel a little bit lighter. If we look at this rocket here we go, this space shuttle, which was retired a few years ago, sadly, and there are a number of forces acting on it. We've got this thrust force caused by the engines, the rocket engines. We've got the force of gravity, which is trying to make it fall back down again. Okay. So, what can a force do? I like this little animation. It's a nice, simple key stage 3 one. Here's a guy with a crossbow about to shoot this bloke here. Look. First of all, the force causes the arrow to accelerate. It makes it change its speed. The arrow then crashes into that shield and causes a deformation. It changes the shape of the shield. And then the force of the rebound causes the arrow to change direction. So very simply, we can say that a force can change the speed, shape, or direction of something. Here are some other examples of forces. Here we go. You may have seen this before. This is the magnetic force. We know this is the electrostatic force. This is a Van de Graaff generator, and this is representing just the force of gravity acting across space. So these are all 3 examples of non-contact forces. You can read that. Some essential notes. This is what you need to learn. Okay, now here's an exercise which I want to have in a mark. So this text here will be in the accompanying file so you can read it properly, and it's a simple reading for comprehension. I'm not interested in the summary questions on this text. I'm just interested in that you read the text and comprehend what it means, and the questions will be marked against these criteria. Now the questions are my questions, which are also attached. So we're looking for these sorts of levels of answers. Ideally, we're looking for level 2 to level 3 in your writing. We're not really that interested in just one-word answers. Okay, that won't score well in exams. So this is what the questions look like, and these are attached as a document. So, true or false? Write down the numbers 1 to 10. See if you can do these. Forces are a type of energy. Units of force are newtons. Forces are scalars. You can fall through a black hole. Magnitude of most force fields diminish with distance. Is that true or false? All masses create a gravitational field. Is that true or false? Mass and weight are measured in kilograms. Electrostatic forces are trying to explode the nucleus of atoms apart. Only magnets have magnetic atoms. And you can see forces. Okay, that's false. False. True. Oops. False. False. You can't fall through a black hole. A black hole is basically a very dense star. The magnitude of force fields diminish. That means to get smaller with distance. That is true. The further away you are from something, the smaller the force. The electrostatic force or the gravitational force gets smaller with different distance. And it is true that all masses create gravitational fields. Even your own mass has a gravitational field associated with it. We don't measure mass and weight in kilograms. That's rubbish. Mass is in kilograms, weight is in newtons. Electrostatic forces are trying to explode the nucleus apart. Think about protons in the nucleus. They're all positive, and they are trying to repel each other. The force which keeps them in the nucleus is the strong force. That's why it's called the strong force, because it's stronger than the electrostatic force at that region of size. Okay, all atoms have magnetic properties, and you can't see forces. Okay, so enjoy, leave it there, have a go at the homework, have a go at the comprehension, and I'll mark that in real life, or you can mail it in to me if we can't get into school. Cheers.